que quisiera verla con una traducción.
Ya,
Claro.
Es mejor. Yo hace la charla en inglés y después se hace, o usted hacen una traducción en español para el YouTube. Es una buena idea.
Perfecto.
Porque con una traducción simultánea no tenemos todo el tiempo suficiente.
Listo. Entonces tú eres el moderador, Marcos. Marcos es el presidente del FIRMA, pero es el moderador, el novio de la madrina, es todo. Entonces, Marcos, haces el anuncio de que va a ser en inglés.
Hay que ponerse corbata, Marcos.
Sí. Ya estamos transmitiendo en vivo vía YouTube.
Marcos, si quieres ponme de hospedador, así puedo ir poniendo coanfitriones a los ponentes que faltan.
Listo.
Hola, buenas tardes. ¿Se me oye?
¿Tú me escuchas?
Perfectamente. Sí. Quería saber si se me oye a mí.
Perfecto, sí.
Gracias.
Si me puedes hacer coanfitrión y Omar.
Sí.
Ok.
Vamos.
Ok, voy a comenzar compartiendo mi pantalla. Vamos a pasar un homenaje póstume al doctor Julio Eduardo Pérez Ramírez. Si se escucha el audio.
Sí, se escucha perfecto.
las 12:32, hora Panamá, Ecuador, Perú, Colombia, podemos dar inicio a la inauguración de este evento. Primero que nada, bueno, quiero darles la bienvenida a todos y agradecerles, bueno, mi lista de agradecimiento es muy grande. Quiero agradecerles a todos los ponentes y conferencistas que nos están acompañando en este evento, pero también quiero agradecerles al comité organizador, tanto central como el extendido. Somos 51 personas del comité y representantes de todos los países, los 21 países de Iberia, Maricruz, que nos han dado todo el apoyo para que este evento pueda llevarse a cabo y que ya estamos viendo el éxito que habíamos podido prever, consolidando ese éxito. Bueno, sin más participantes en el evento y todas las actividades que tenemos preparadas para ustedes, estamos muy seguros de que va a traerles muchísima información y que esto va a ser enriquecedor, les va a permitir ponerse al día con mucha de la información que se va a discutir en este evento. Tenemos casi 200 trabajos que son contribuciones de los participantes del evento y tenemos 56 ponentes que van a estar hablando en diferentes temáticas que van a traer un mundo de información. No podemos dejar atrás, bueno, a todos los patrocinantes, a los patrocinadores que nos han dado su apoyo y vamos luego a hablar un poquito de ellos para hacerle el honor que merecen. Sin más, quisiera presentarles no sé si pueden ver mi presentación. ¿Sí pueden ver mi presentación?
Sí, se observa.
Perfecto. Bueno, entonces, sin más, voy a darle paso a Alejandro Flores, que es oficial de Pesca y Acuicultura FAO para la América Latina y el Caribe. Alejandro, ¿estás con nosotros?
Sí, aquí estoy. Muchísimas gracias. ¿Me escuchan bien?
Perfectamente.
Muy bien. Pues muchas gracias. Bueno,
voy a dejar de compartir pantalla.
Correcto.
Para que podamos ver tu...
Muy bien. ¿Tú me indicas?
Adelante.
Ok, muchas gracias. Bueno, pues primero quisiera agradecer la invitación para participar en este muy importante evento. En nombre de la FAO, de la Organización de las Naciones Unidas para la Alimentación y la Agricultura, quisiéramos extender una muy cordial felicitación a ustedes que constituyen el comité organizador por la excelente convocatoria que hemos podido percibir, el excelente nivel y por supuesto todo esto habla de una excelente organización. El día de ayer concluyó justamente la sesión número 34 del Comité de Pesca de la FAO, que es el único foro intergubernamental a escala global que discute, intercambia, debate y acuerda decisiones en torno a los asuntos del desarrollo de la pesca y de la acuicultura. La comunidad internacional, a través del COFI, como llamamos por sus siglas en inglés, hizo acuerdos y compromisos muy importantes en torno, por ejemplo, a impulsar, por supuesto, una mayor contribución de la pesca y la acuicultura en 4 pilares fundamentales de la FAO, que son, diría yo, universales: una mejor nutrición, un mejor ambiente, una mejor producción, más sostenible, y todo esto para una mejor vida, mayor bienestar de la población. También se acordaron aspectos relacionados como implementar un plan de acción global sobre resistencia a los antimicrobianos, redoblar esfuerzos para combatir de manera frontal la pesca ilegal, no declarada y no reglamentada, que sigue siendo un flagelo importante a escala global, así como fortalecer la resiliencia de las comunidades que se dedican a la pesca y la acuicultura alrededor del mundo a los efectos del cambio climático. Así que, como ustedes ven, estos temas de la agenda internacional, no solo de la FAO, sino de las Naciones Unidas, pues se relacionan mucho con muchos aspectos que ustedes tocan en su evento. Así es que yo en lo personal me congratulo de ver múltiples trabajos, esfuerzos académicos orientados a contribuir con un pequeño grano de arena a estos temas tan complejos a escala global. Una reflexión que quería compartir con ustedes es también que probablemente quienes están en universidades, en institutos de investigación, pues puedan percibir también, como nosotros, que hay una contracción muy importante en la matrícula de estudiantes que tienen interés en ciencias del mar, en las ciencias acuáticas y en todas las ramas que inciden, ramas del conocimiento que inciden justamente en el aprovechamiento sostenible de los ecosistemas acuáticos. Y esto pues en realidad es preocupante porque cada vez más se necesitan pues de ir generando conocimiento más rápido, de incorporar más personas a este concierto de población que se dedica a la captura, al cultivo, al aprovechamiento en general, espero, sostenible de los recursos acuáticos. Así es que la labor de ustedes es fundamental, la labor de FIRMA, que al cumplir ya su 10ª edición, habla de que el contenido, el nivel, es no solamente muy bien recibido por la comunidad académica y de productores, sino también que resuena en otros ámbitos como la organización a la que yo represento. Y bueno, no me queda más que felicitarles por estos esfuerzos, decirles que la FAO no solo está consciente, sino muy decidida, determinada como organización a tener vínculos cada vez más cercanos con la academia. A final de cuentas, la investigación científica, el desarrollo tecnológico, la generación de conocimiento es fundamental, es vital para avanzar en la solución de los problemas tan complejos de los ecosistemas acuáticos. Así es que nuevamente felicidades, enhorabuena por este 10º aniversario y les deseamos que sean muchísimos más y cuenten con nosotros para acompañar sus esfuerzos. Muchas gracias.
Muchas gracias. De verdad, un placer tenerlos a ustedes aquí. Alejandro, gracias por esas palabras. Y creo que son puntos bien importantes los que tocas. Creo que la sostenibilidad es uno de los puntos críticos para el futuro de este planeta. Vamos a darle la palabra entonces a Javier.
Hola.
Javier Garat.
Sí. Hola, buenas tardes desde Madrid, España. Buenos días a todos los que estáis en Iberoamérica y a todos los que nos estén escuchando y viendo desde un montón de lugares del mundo. Muchísimas gracias también por contar conmigo y con la industria pesquera, las organizaciones del sector pesquero, en este caso como presidente de ICFA, la Coalición Internacional de Asociaciones Pesqueras. Decía Alejandro que la semana pasada se celebró el Comité de Pesquerías de la FAO, el COFI. A lo largo de una intensa semana, como bien decía, se han negociado un montón de aspectos relacionados con la gestión pesquera y se reconocía en uno de los puntos, se señalaba, y lo voy a leer textualmente, la importancia del sector de la pesca y de la acuicultura para la mejora de los medios de vida, la reducción de la pobreza, la seguridad alimentaria, la nutrición y la salud humana, y sus interrelaciones con la conservación y el uso sostenible de la biodiversidad, entre otras cosas, así como la importancia de adoptar un enfoque integrado a fin de encontrar un equilibrio entre las compensaciones recíprocas. Estamos hablando, y vamos a hablar a lo largo de todas estas semanas, de la proteína animal más saludable que existe en el mundo y además con menor impacto de huella de carbono en su producción y que, como digo muchas veces, provoca felicidad en las personas que lo consumen. Y eso hoy en día, en estos tiempos tan tristes de COVID, por todo lo que estamos pasando, yo creo que es algo que conviene destacar. Tenemos que velar claramente por la sostenibilidad social, económica y medioambiental, si queremos seguir alimentando al mundo de forma responsable y de forma sostenible. Está demostrado que la buena gestión de los stocks funciona y, por lo tanto, yo creo que nuestro objetivo común tiene que ser que en todo el mundo se apliquen buenas medidas de gestión para sacar el máximo provecho posible a los recursos naturales que nos ofrecen nuestros océanos. Y estoy convencido de que la mejor forma de gestionar es la que nace de la colaboración entre los científicos, los pescadores, el sector pesquero en general, las distintas administraciones y las ONG que apuestan por el uso sostenible de los recursos naturales. Y qué duda cabe que este tipo de foros, y en particular este en concreto, el Foro Iberoamericano de los Recursos Pesqueros, Marinos y Acuícolas, nos brinda una magnífica oportunidad para debatir entre todas estas partes interesadas sobre todos estos temas que sin duda a lo largo de esta semana vamos a ver que son de actualidad. Este año tiene un alto contenido en acuicultura, en las ponencias a lo largo de la semana, pero estoy convencido, y ya lo he hablado con los organizadores, que en las próximas ediciones podremos también incluir más sesiones relacionadas con la pesca para que se pueda equilibrar tanto la pesca como la acuicultura, y ahí creo que será importante la colaboración con Alpescas, la Alianza Latinoamericana para la Pesca Sostenible. Organizaciones de distintos países de Iberoamérica que se han unido en esta alianza para fomentar la pesca y el comercio responsable. Así que lo único que puedo, para terminar, es desear que sea un éxito rotundo este foro, que anime para que en las próximas ediciones podamos seguir hablando de todos estos temas pesqueros, que encontremos muchos patrocinadores que hagan posible que este foro se pueda repetir cada año, y termino diciendo que disfruten todos ustedes comiendo pescados y mariscos. Serán felices y además será la mejor forma de ayudar a los pescadores a continuar con esa labor tan importante como sector esencial y estratégico, como hemos sido declarados en esta pandemia. Muchas gracias.
Muchas gracias, Javier, por estas palabras. Sí, creo que tiene impacto estas conversaciones que tuvieron esta semana que acaba de terminar. Y indudablemente la pesca y la acuicultura son elementos esenciales para la reducción de la pobreza y el desarrollo de toda Iberoamérica, que es lo que nos trae aquí a todos en esta oportunidad. Bueno, vamos a darle la palabra entonces a Manuel Rey, quien es... Déjame compartir pantalla. Quien es el presidente de la Asociación Cultural de Foros y podemos decir que es el padre del Foro Iberoamericano de los Recursos Marinos y la Acuicultura. Manuel, tienes la palabra.
Gracias, Marcos. Vamos a ver. ¿Dónde ver esto? Ahí. Muy bien. Bueno, antes de nada, un saludo desde Galicia, España, a todos los asistentes a este acto inaugural del X FIRMA, agradeciendo a conferenciantes, ponentes, investigadores, empresas, administraciones y colaboradores su participación y apoyo en este evento. El FIRMA nace en el año 2007 en el entorno y siguiendo el modelo del Foro dos Recursos Mariños e da Acuicultura das Rías Galegas, Foro Acui, que se celebra anualmente desde 1998 en la isla de La Toja, en Ogrove, España, con el fin de debatir y poner al día los avances y problemas en relación a los recursos marinos y a la acuicultura en los países iberoamericanos, a través de un evento en el que pudieran interactuar científicos, administradores, empresas y la sociedad. De esta forma, el primer FIRMA se celebró conjuntamente con el 10º Foro Acui en Ogrove, Galicia, España, con el apoyo de la Xunta de Galicia, la Universidad de Santiago de Compostela y la venezolana Universidad de Oriente, que fue la encargada de realizar el segundo FIRMA en el año 2008, en la ciudad de Cumaná, coincidiendo con el 50 aniversario de la creación de esa universidad. A continuación, con periodicidad anual o bianual, se celebraron firmas en México, Hermosillo en el año 2010, Portugal, en Viana do Castelo 2011, en España, Cádiz 2012, en Chile, Valparaíso en el 2013, Ecuador, Machala 2014 y también Portoviejo en el año 2019 y Perú, Tacna en el 2016. Todos ellos fueron organizados por fundaciones, institutos politécnicos, universidades, gobiernos regionales y estatales o redes del Programa Iberoamericano de Ciencia y Tecnología para el Desarrollo. El FIRMA tiene, además de su interacción entre ciencia, empresa, administración y sociedad, la característica de la publicación extensa de los trabajos presentados, quedando, por tanto, una huella permanente de las aportaciones realizadas en cada foro, así como la organización de cursos precongreso de muy buena acogida y que permiten a estudiantes profesionales discutir sobre perdón que se me coló esta. De muy buena acogida y que permiten a estudiantes y profesionales la puesta al día de temáticas relacionadas con los recursos marinos y la acuicultura. Aunque en esta ocasión, y debido a las circunstancias que sufrimos por la pandemia, se realiza por primera vez un FIRMA online, con una gran participación, por cierto, a nivel por lo menos de inscripción, debido sin duda al gran plantel de especialistas invitados, posiblemente echaremos de menos la posibilidad de interacción personal directa, así como compartir y disfrutar de actividades lúdicas y conocer nuevos lugares, pero estoy seguro que lo recordaremos por la gran calidad de las aportaciones que se realizarán en él. Bienvenidos a la familia Firma y muchísimas gracias por su participación. ¿Listo? ¿No se escuchó?
Se escuchó perfecto, Manolo. No sé,
Marcos o Omar, no sé, deberían dar continuidad.
Sí, bueno, yo voy a tomar la palabra porque soy el que va a continuar. Marcos debe estar por algunas cosas y esto siempre pasa. Bueno, gracias Alejandro, gracias Javier por tus palabras y recomendaciones. Sí, la verdad, este firma, pues hay un sesgo más hacia acuicultura y pensamos que hay una tarea pendiente con lo que es pues los recursos marinos como tal, la pesca y sobre todo la biodiversidad, que es importante. Yo estoy muy honrado de haber llegado aquí, mis queridos estudiantes, profesionales, empresarios, colegas interesados en los recursos acuáticos y la sostenibilidad del planeta. Es para mí un honor haber llegado a esta 10ª edición del FIRMA con nuestra visión de sinergia entre la industria para el desarrollo y la sostenibilidad de los recursos acuáticos y la acuicultura de Iberoamérica. Y no ha sido nada fácil. Desde que el Comité Central, en octubre del año pasado, hace tan solo tres meses, decidimos pues sobreponernos ante la situación de la pandemia y reinventarnos para que el FIRMA continúe siendo precisamente lo que es. Una firma de excelencia donde se siga discutiendo sobre nuestros recursos y la acuicultura, más aún con la mayor necesidad en estos nuevos tiempos, donde tenemos, óiganme bien, la responsabilidad histórica para la producción con la menor huella ecológica posible, y más en los tiempos de pandemia que están sufriendo nuestros países y en particular nuestros países iberoamericanos. No habríamos llegado a este punto ya con unos 1.500 inscritos codificados y unos 200 trabajos científicos en este firma, si no es por la colaboración interesada, pero en la discusión de problemas con pasión para el desarrollo de más de 55 especialistas internacionales que tienen este evento hoy. Ninguno de ellos, comenzando por el muy ocupado doctor Daniel Pauli, a quien conocí hace tiempo en Venezuela, brindándole una exquisita y añorada arepa, puso resistencia o reparos a la convocatoria o poder acompañarnos. Nadie de estos investigadores. Más bien tendieron una mano para colaborar más. Por ello, en nombre de la organización FIRMA, les reiteramos nuestro mayor agradecimiento. De igual manera, a los capacitadores de la 20ª de cursos especializados que ya se desarrollaron esta semana con total éxito. Muchas instituciones, decía Marcos, y empresas nos han apoyado para realizar este evento. Esperemos que sean más para el próximo, tanto como auspiciantes o como patrocinantes. Quiero nombrar en especial a la Universidad de Oriente de Venezuela, quien con su actual rectora, doctora Milena Bravo de Romero, pudimos dar inicio al FIRMA, ¿verdad? Como lo ha dicho Manolo, nuestro compañero y amigo doctor Manuel Rey Méndez, que junto con Jacobo Fernández, de la Nueva Pescanova, presidente de Foro Acui, y Alejandro Guerra, de la Junta de Galicia, y Nieves, por supuesto, siempre acompañando el FIRMA, Nieves González, pues el FIRMA se inició de la mano del Foro Acui. Agradecimientos mil a la Asociación Cultural del Foro Acui, evento madre del FIRMA. Agradecemos también a la siempre acompañante Universidad de Santiago de Compostela y la Universidad de Las Palmas Gran Canarias de España, la Universidad Científica del Sur, a quien se debe pues uno de nuestros hermanos del Comité Central, Paul Baltasar, a la Universidad Laica Eloy Alfaro de Manabí, quien también se debe nuestro José Alió también como organizador, y de quienes hemos recibido un gran apoyo de parte de su guía a la universidad, al rector el rector Vicente Vélez Briones de la Universidad Técnica de Manabí, a quienes nos debemos Jorge Sonel-Horsner y este servidor, estamos trabajando y dando nuestros servicios. Existen muchos patrocinantes del FIRMA 2021 online, Marine Instrument, Megasupply, Analytic, Illumina, la Sociedad Española de Acuicultura, Tunacons, Asoproco, o sea, la Asociación de Productores de Camarones de Occidente de Venezuela, y creo extendiéndose ahora a toda Venezuela como una asociación, y sus empresas asociadas como La Mar, gracias al empeño del doctor Fernando Villamizar, también vocal por Venezuela de este 10º FIRMA, fundaciones como Mar Viva y la Fundación Polar, organizaciones en la comunicación como IPAC, Acuicultura, Panorama Acuícola, Industria Acuícola, mispeces.com y Azul Sostenible TV. Grupos de investigaciones y desarrollo de la Universidad de Las Palmas Gran Canarias como Ecoaqua y Aquaetzel, empresas como Aqualgae, Asociación Norteamericana de Rendizados, NARA, Lanterne.com, Aquatec, siempre Sergio Nate ayudándonos, Estrumar del Grupo Quintá, Moca Consultores Tecnológicos, que han aportado para el desarrollo de este evento. Es importante nombrar que muchas de estas compañías y asociaciones como Asoproco, Polar, Mar Viva en su radio acción Colombia, Panamá, Costa Rica, NARA, Aquate y Megasupply, con sus donaciones han permitido que junto con la organización FIRMA poder becar a estudiantes e investigadores de países de extrema situación económica para que estén participando hoy en día y capacitándose, porque creemos que el FIRMA lo estamos diseñando para ser un capacitador. Fehacientemente creemos que este es un acto de colaboración para mantener viva la ciencia y el desarrollo que ello conlleva en dichos países. Muchas gracias por sus aportes. Pero no pudiéramos haber llegado a tal punto hoy en el FIRMA sin la colaboración acérrima del Comité Central, comandado por nuestro presidente, el doctor Marcos de Donato, y de los más de 40 vocales y corresponsales de este 10º FIRMA 2021 online. Representantes de países iberoamericanos y otras regiones del planeta. Y también de los invisibles, el equipo en una persona de las redes sociales, Grades, edición del libro Maricruz, Rosa en la administración de los cursos, un batallón operadores Zoom atrás de sus pantallas comandados por Ezequiel y Jorge, e indiscutiblemente Víctor, responsable de la programación informática de este evento. No quiero dejar atrás a los participantes interesados en este evento, es la médula, sobre todo los estudiantes, y a los que también invisibles, pero más importantes, nuestras familias que nos dieron paso, atención y disposición en nuestros hogares para que podamos armar y celebrar el hoy 10º FIRMA 2021. Así que en nombre de la organización FIRMA, muchas gracias a todos, y dejo la palabra a Marcos, nuestro presidente, hoy también moderador en este acto, para que nos pueda ilustrar con un tour, Marcos, si puedes y hay tiempo, de la página web del 10º FIRMA 21. Gracias por su atención.
Muchas gracias. Estamos sobre el tiempo. Es hora de la conferencia de Daniel Pauli, pero como es una página nueva, vamos rápidamente a mostrarles cómo funciona. Muchos ya estarán familiarizados porque entraron. La dirección es firmaonline.org, /firma foro, y les aparece este screen y simplemente ponen la dirección con la que se registraron y decir si estoy inscrito, y entonces van a poder acceder a el programa que está dividido por día. Nos toca hoy domingo. Hoy domingo vamos a tener una sala y tienen la forma de la conexión directamente aquí. Le dan clic y de una vez se abre el Zoom para poderse conectar. Y bueno, estas son los diferentes links al Zoom. Y aquí pueden navegar día a día todos los programas. Y los trabajos están aquí dispuestos en formato póster electrónicos y videos que podrán acceder en las diferentes categorías. ¿Okay? Cualquier duda, estamos a su disposición. Estos trabajos, este sistema, esta plataforma que hemos desarrollado, podemos dar aquí entrada y en la página pueden ver el trabajo, ya sea en póster, PDF o en video, y tiene un sistema de comentarios donde pueden hacer preguntas a los autores y poder interactuar los autores con el público que está atendiendo. Si tienen alguna duda, bueno, estamos a la orden. Cualquier cosa nos pueden contactar. Pueden hacer preguntas y le damos entonces, vamos a dar paso directamente a lo que es la presentación de Daniel. Voy a compartir mi pantalla ahora para hacer una introducción. Ya pueden ver mi pantalla. Hoy es un gusto tener al doctor Daniel Pauli de la institución Sea Around Us y Institute for Ocean and Fisheries de la University of British Columbia, Canadá, que nos trae una conferencia titulada La teoría de la limitación del oxígeno branquial, aplicaciones a los peces e invertebrados de Iberoamérica, y que es una teoría que explica cómo el cambio climático afectará a las poblaciones de organismos acuáticos y sus consecuencias en las pesquerías. El doctor Pauli es nacido en París, Francia, en 1946, hizo su doctorado en biología pesquera en la Universidad de Kiel en 1979, tuvo sus comienzos en investigación en el Centro para la Gestión de Recursos Acuáticos Vivos y CLARM en Manila, llegando a ser su director. En 1994 se incorporó al Instituto para los Océanos y la Pesca de la Universidad de Columbia Británica en Canadá, donde hoy posee la máxima distinción académica, University Killam Professor. Es uno de los científicos con mayor repercusión en las ciencias naturales y pesqueras. Lo avala sus más de 1000 publicaciones entre artículos, libros e informes. Pauli también es co-desarrollador de proyectos célebres de modernización de software como EcoPad, la enciclopedia online Fishbase y las series temporales de captura de Sea Around Us, un trascendental proyecto que estudia desde 1999 el impacto de las pesquerías en los ecosistemas marinos de todo el mundo y del cual es investigador principal. Con esto, quiero darle paso a Daniel para que nos haga su presentación.
Voy a hablar en inglés porque mi español es muy problemático. Hay muchos errores y otros. y voy a hablar inglés. I will share my screen with you. Share screen. There we are. There we are. You see my screen. And so I know essentially I have been working in most Latin American countries, in Ibero-America, all of them, most of them. And I have been working on the fisheries mainly. But there is another way of looking at fisheries and fishing, which is to look at the fish themselves and look at what the problem is. And the problem of fish actually is a problem that we don't have, which is breathing. Why is this a problem? Because for fish, it is very difficult. And when I mean fish with fins, and I mean also invertebrates like shrimp and squid and other invertebrates, because they are very similar to fish in this regard. So it is very difficult to get the oxygen that you need if you are a fish. A liter of water, for example, contains 30 times less oxygen than a liter of air. And the water is very much more viscose than air, and it's more dense. So moving the water is much more difficult for the fish than for us to move the air back and forth in our lung. And the diffusion of molecules is 300,000 times slower in water than in air. So breathing is actually a problem for fish. And this is why they have evolved in the course of millions of years. They have evolved big gills, branchiae. You see here fish-like animals that lived 300 million years ago, and the reconstruction of their anatomy suggests that they had very small part of their head was devoted to breathing, and they had clearly inefficient gills. Now, if you compare this with modern fish, for example, a carp or a basking shark, one of the big sharks, you can see that the head of modern fish is full of gills because they must breathe. Now, you can have very small heads in big fish, like, for example, arapaima, but they don't breathe with gills. And in fact, the arapaima will die if you keep them in water. They have to come and breathe air. So to understand the way gills work, we have to make an analogy with the radiator of cars. In the front of cars, you have radiator that cools, that are there to cool the water that cools the engine. Now, the engine motor produces hot water, and the hot water gets into the radiator, and the radiator have lamellae. So the hot water goes through the lamellae, and the heat in the lamellae is taken away by the air that goes through the lamellae. And you can understand right away that you could not make a radiator work more efficiently if you put a radiator behind the radiator, because the radiator would get hot air in the lamellae that is behind, and so it wouldn't work. So if you want to make a radiator bigger, you have to make it wider or higher, but you cannot make it deeper, because deeper doesn't work. Now, fish have exactly the same problem. They have lamellae to get the oxygen out of the water, and once the water has gone past the lamellae, after the lamellae, there is no more oxygen in the water. So there is no point putting another gill after the water has been through the gill. That means gills, bronchi, are really a surface. They are a surface. They do not work as a three-dimensional object. They have 2 dimensions, not 3. So if you look at the carp, it means that you see the line with a black line on top. It grows. This line will grow slower than this is the gill area, the superficie of the gills. It doesn't grow as fast at the volume as the weight of the fish. That means the fish, as it gets bigger and bigger and bigger, has less superficie surface of the gill per body weight. So per body weight, they have less and less oxygen and less gill area, and thus less oxygen. A big fish has less gill area per unit weight than a small fish. And so it cannot do lots of things, a big fish, than a small fish because of this. So if you look at the picture in A, the gill decline, the gill per unit weight, the gill per weight, declines as the weight increase. It gets so low that at a certain point, the fish cannot grow anymore because it doesn't get enough oxygen. If this level of oxygen supply, we call it maintenance metabolism. Now you can see the maintenance metabolism is very much a function of temperature. So if you increase in picture B, if you increase the temperature, then the metabolism goes up. The fish has to be smaller. It has to become smaller because the body weight at which the oxygen supply and the oxygen demand become the same is smaller. And that's basically the main problem that fish have. As they get bigger, they get less. But if the maintenance metabolism is increased by increasing temperature, then they have to be smaller. So we wrote a paper about this in 2013. We could show that little what is his name, Nemo, would be smaller under global warming. And I will try to explain this. This is not very exciting, but I will have to explain how this happens. So the growth of a fish, that is the delta W dt, dW dt, the growth rate, is a function of oxygen that it gets through the gills, because you need oxygen to synthesize body substance. So you have the growth of the fish is a function of protein synthesis, and the protein synthesis is depending on the rate at which the gill declines with body weight. They increase with body weight, but not as fast. And the difference between the two is this 0.8 or 0.6 or 0.7. And larvae don't have this problem. Fish larvae grow exponentially, but when they get to metamorphose, when they get scale on their body and their breathing becomes only gill-based, the rate of growth of the gills changes, the rate of growth of the gills changes, and they start growing like the adults. So everything depends on this gill size and energy metabolism. Now you see that the protein synthesis is taking place as a function of oxygen and gill size, and there is a minus effect, a negative effect, that is the protein degradation. Essentially, every time you synthesize a protein, this protein will after a while degrade. And sorry, there is a little problem in my presentation. There is a little problem in my presentation that where's the damn thing? There is a little problem in my presentation, and I will have to see. Okay, so we can everything depends on energy metabolism and on which is fed by oxygen, and which determines how much protein can be synthesized. Now you can see that if a fish spends lots of its energy, uses lots of its oxygen to move around because it is wild, it's bravo, it is wild type, then it has less energy for growth. The energy metabolism is used for activities, whereas if the fish is quiet, it's used for protein synthesis. And so a fish that is quiet, that is domesticated, will grow very fast, whereas a wild type grows very slowly. That's the reason why in aquaculture we want to have quiet fish. And also it's the reason why we want to aerate ponds. These pictures are from China, and you can see that in Chinese aquaculture, they spend a huge amount of money on aerating the ponds because you need oxygen for the fish to grow. Now, therefore, gill size is the important factor in fish growing, and the various activities that the fish undertake, they all work against growth. In other words, a fish can be very active, very challenged, it can be exposed to all kinds of problems, but then in that case, it doesn't grow well. And we can actually explain through this simple model why we have so paradoxes. The first paradox is that that in most species, about 80% of the species, the female get bigger than the male. And many people believe that fish stop growing, their growth stops at some point because they reproduce. But if this is true, if this is correct, then the female should always be smaller than the male, because the female invests far more than the males in reproduction. In reality, the female actually get bigger because they are more quiet. The males are always fighting and messing around, and they waste the oxygen on activities, and the females don't do that that much. In other words, we had a contradiction that we can resolve if we understand that oxygen is a limiting factor. Also, for aquaculture, it's very important the fact that as a fish gets bigger, it converts the food conversion efficiency. The conversion of food into growth declines, and it declines because they have less oxygen than when they are big than when they are young. It is extraordinary, but if you look at the literature, if you look at the reference that are available, there is no good explanation why the food conversion efficiency of fish declines with size. And the reason why it declines with size is because they have less oxygen per unit weight. And you can see this in aquaculture. If you farm a fish, you need less and less per unit weight as they get bigger, because they don't grow anymore. And really at the end, when they are very big, they will not grow but eat, and they eat what is needed for maintenance. So in aquaculture, you never wait until the fish is big. You always market them earlier. Now, this business about oxygen being limited also explains why young fish and young mussels and clams and oysters and so on, why they have daily rings in their otoliths. They have rings that you can see, and the adults you cannot see these daily rings. Their daily rings, you can see them, they are formed by a variation of the pH. When the fish is very active, the oxygen level in its blood sinks, the oxygen level in its tissue sinks, and the pH sinks also. In other words, when a fish is very active, it is out of oxygen, and the pH or in the body gets very low. And a low pH, as we know, is acidic, and this will make a mark on the otoliths. And at night, when the fish is quiet, it recovers, and the synthesis of matrix for the otolith is again process is again active, and so you have daily rings. And this is funny, but there is no other good explanation as to why there are daily rings in fish. And in the otoliths of fish, the small fish have nitrogen, contain nitrogen. The big old fish do not. This is because, again, they have no access to oxygen when they are old. Also, most young fish contain lots of oxidative enzymes in their body, and old fish of the same species, big old, contain glycolytic enzyme, which means that basically they in old fish operate in an environment, in the tissue, the body has little oxygen available. I will skip that. Now, the question as to why the fish spawn when they do, you probably have in the textbook, they tell you that the fish spawn when the eyes perceive certain cues, for example, light or other cues that are used to produce a hormone in the pituitary gland, and then this hormone triggers another hormones and another one, and you have a series of hormones. And this cascade is then the reason why they start spawning. The problem with this, however, is that a fish that lives, for example, several years, a fish that lives 30 years, will spend the first year of its life without perceiving the environment that tells it that it should spawn. It's like a child that doesn't see people of the other sex. For example, my son, when he was 8, did not see the beautiful ladies. He saw them only when he was 13 or 12 or 14, because his body was not ready to actually see them. And it's similar with fish. When a fish grows, its oxygen supply declines, as presented before. And at some point, it will become so low that they cannot grow anymore. So clearly, they have to spawn earlier than that. So in A, you can see that, for example, they spawn at WM. This corresponds to a level of metabolic rate of oxygen consumption that is higher than at the maximum they can reach. And this, there is the ratio between QM and Q infinity is there. You can see it. Now, if you put this fish in warmer water, it will have an elevated metabolism. It will therefore stay smaller, because the maintenance metabolism cause it to be earlier at a smaller size, supplied with just enough oxygen. This means that it has to spawn at even smaller size. So QM and Q infinity also will have to have a ratio. It turns out that the ratio between these two, A and B, is actually the same. Come on. Sorry. There is the ratio. Basically, the length at first maturity of fish and is related, obviously, to the metabolic rate, and the length at first that the maximum maximum size they reach is also related to the metabolic rate. So you can re-express the metabolic rate in terms of length, and you can actually calculate this ratio, 1.36. That means when a fish has reached a size where its metabolic rate is 1.35 or 36 of the lowest metabolic rate that it can have, then it will spawn. Now, why is it important? Because it applies to all fish. The small fish here are guppies. The big fish here are tuna. And this was published in '84. This has been, in the meantime, reproduced for salmonid. It has been reproduced for tilapia. It has been reproduced for coral reef fishes. It applies to all fish. And we are working with colleagues in Brazil and other places that will who show that it also applies to shrimp and to other animals. So basically, the factors that reduce the maximum size of animals, of animals that breathe water, fish and shrimp and so on, is also the factor that reduce their size at first maturity. So anything that reduces the size of an animal in the water will reduce the size at first maturity. The two things go together. because this relationship 1.36 is more or less fixed in all animals. That was a very new finding. Okay, now, sorry, this is too, okay. Another important feature of fish, including fish that occurs in Ibero-America, is that when they are bigger, when the temperature is low, the fish that can handle cold temperature, they will get bigger at the colder part of their range, and this is demonstrated for thousands and thousands of species. And you can see that if you take, for example, flatfish in the North Sea, where the small ones occur on the coast and the big one occur in deeper water. But you can also see that in Hawaii with mero, with groupers and snapper and other fish, where if you plot the size against depth, you can see that they get bigger and bigger in deeper water. Why? Because the temperature is cooler in deeper water, so they reduce the oxygen requirement, and therefore they can grow bigger. Remember, as a fish gets bigger, it has very little oxygen. So the best way to continue growing is to reduce the oxygen requirement. And the fish do that by going into deeper water. Another thing is that the migration of fish also get explained that way. Because, for example, in West Africa, I couldn't find something that clear in South America. So I'm showing a West African example. The sardine and other fish, they move back and forth, north, south, seasonally, from Senegal to Morocco and back in the course of a season. And you could ask yourself why they do that, why they do this migration. But if you plot, instead of plotting the geography, if you plot the temperature simply, you can see that the fish migrate in order to stay in the same temperature. And this is very important because when fish migrate, people always explain this in terms of they going there to get enough food, or they going there to reproduce. Actually, it's not so. What they do is they try to stay in the same temperature range. And then in the course of this migration, they eat and they spawn, but that's not the reason why they migrate. So, because fish are very dependent on exactly being in the same, in a proper temperature for them, because getting enough oxygen is a problem, we can plot with the increase of temperature that is due to global warming. We can plot the migration that fish will experience in the future. And this is a paper that was written by a number of our colleagues, with a number of colleagues. And this was the first map that showed the migration of fish and fisheries that will occur in 30, 40 years. You can see that there is a intertropical belt of reduction of catch that will be due to the fact that the fish are leaving the tropics and moving toward the poles. And that is a big problem. And this is the reason why this map was used by the IPCC, the Intergovernmental Panel on Climate Change, to show. That was the first map of that they showed in a fifth assessment for the effect of climate change on fisheries. Now, what I showed you is a projection. We can actually global change, global warming has already happened, and from 1970 to 2009, for example, this change have already happened in a with a strong warming in the Atlantic, in the North Atlantic, and in East Asia. Now, we can actually show this this effect, this migration effect that has happened in the past already. We can show that using a new concept. That is the mean temperature of the catch. You see, if you have a group, if you catch fish of different species, say with a trawl, each fish has a preferred temperature. This species here has 8 degrees, this one 10, this one 6, this one 12. Could be the same with this species in Venezuela, caught in Venezuela, has 26, this one 25, and so on. The preferred temperature of a fish is easy to assess. This is usually at the center of the temperature of the center of the distribution. And this preferred temperature doesn't change rapidly. It takes millennia to change the temperature preference of a fish, and therefore you can actually treat it as a constant. Now, you can, if you have a catch of a country, for example, you can compute the average preferred temperature weighted by the catch. We call it the mean temperature of the catch. And if you look at the upper picture, in subtropical and temperate ecosystem, the mean temperature of the catch is more or less the same as the temperature itself. It increases, and this is due to the composition of the catch changing. You see, if you take a country like let's say Argentina, it will have fish from Brazil, and increasingly, because Brazil is warmer, and this warm water fish leave to Argentina. And in Peru, they will have more fish. They will export fish to Chile, as they do when there is an El Nino event. And in North America, we see that because we are getting now in British Columbia, we are getting fish from Mexico and fish from California. We're getting Humboldt squid, giant squid, in the summer in British Columbia, and on the East Coast, fish from Florida are showing up in New York. And so the mean temperature of the catch for New York, for example, fisheries, would be increased by fish from Florida. And the temperature itself increased, it's parallel. What happens in the tropics, in the second panel below? Well, the temperature is increasing, but the mean temperature of the catch can increase only a little bit. After subtropical fish have left, there cannot be a change in the temperature of the catch, because tropical fish are not replaced in the tropics by hypertropical fish. They are stuck. The tropical fish leave and some stay, but the mean temperature of the catch remains the same. So that means this is a measure of trouble that can be also expressed as shown here. On the right side, on the left side, sorry, you can see the subtropic and temperate water. And basically, we had in there, in the 70s, fish with cold water affinity, blue fish, and a few orange, red fish, subtropical fish. And basically, in the year 2000 and now, the fish with warm water affinity, with cold water affinities, have already left. They are already leaving, and we are getting more warm water fish. In the future, we will have in temperate areas only subtropical fish. And in the tropics, though, the situation is problematic because you start with tropical fish. So basically, you can have only fewer tropical fish. And in the future, this is what caused the decline of tropical fish, of tropical fisheries in the future. I'm really sorry about this, but it is what the future, what you can predict if nothing change. So basically, we will have invasion. We will have invasion in high latitude country of fish from low latitude country, and this will continue to increase. However, we can make better prediction of what fish will do if we really take account of the fact that fish have problem breathing. The regular assumption that people make that that fish must eat. They must eat, obviously, like us, but they have problem breathing that we don't have. We mammals, we breathe air, and breathing is very easy for us, but it is not easy for fish and shrimp and so on. And so we have to look more at oxygen supply in, for example, in farms, in aquaculture, and because feeding is not the major issue in aquaculture, is it preventing having not enough oxygen. So the theory that I call GOLD, the gill and oxygen limitation theory, will be better armed to answer question if you understand that you will better understand the question that the public or politician has about changes in ecosystem that you are responsible for. And everything that I have presented you today, I can send papers that document these things, and I do. All you have to do is to write me at d.pauly@oceans.ubc.ca, and I will send you papers that document these things. So I stop sharing my presentation, and I will answer question if you have any. Thank you very much.
Thank you very much, Daniel. It's a great presentation and very interesting theory that can at least show an explanation to many different issues that have been discussed and unresolved. Muchas gracias, Daniel, por esa interesante teoría que trata de dar explicación a muchos aspectos que han estado siendo debatidos y que no se ha encontrado una solución específica a cómo entender los fenómenos que ocurren. Y esta pareciera ser una explicación válida.
Si hay tiempo, yo puedo dar respuestas o más detalles sobre algunas preguntas que hay.
Vamos entonces a compartir las preguntas.
the Mediterranean. This is one of the areas of the world where the change and the warming is most rapid, especially in the eastern part, because of the Suez Canal, and the invasion is facilitated from the Red Sea. So the Red Sea is invading the Mediterranean, and they have in the Mediterranean big problems with invasive species, and some fisheries have collapsed because of the invasive species. And I have colleagues in Greece and in Turkey that have used the mean temperature of the catch to characterize the changes. And you can see the mean temperature of the catch increasing very rapidly. In Greece, for example, they have an increasing fraction of fish that were not there before.
Very good. One of the consequences of your theory would mean that the stock management should be carried out without the consideration of countries but regional conditions. Is that true?
One of the consequences of this is that when you allocate resources between countries, you have to take into account the fact that in a few years, the fish will have moved. And this is, for example, if you have a series of countries, you have Brazil, and you have the Guianas, and you have Venezuela, or you have Ecuador, Colombia, Ecuador, Peru, Chile. When you have a latitudinal range of countries, the fish are likely to move. And we see that in the US, for example, that the fish I mentioned from Florida are moving to New York. And in Europe, it has caused big problem because they have negotiated agreement to share the stocks between Norway and Iceland, and they took 5 years to get to an agreement. And when the agreement was done, the fish had moved. They had moved to be only in Iceland, so they didn't need to share the stock with Norway, and the negotiation were useless. So this is a real problem, because the fish are moving across political borders.
Great.
Mitigating the effect that I have mentioned, there is basically we should not emit this. The best mitigation is not to emit so much carbon dioxide. On the other hand, the fish are exposed to higher temperature than before. So how they handle it? Well, if you have a very small biomass of fish, if you have only a few fish of a given species, the response of this fish the range of response will be small. They will all do the same. If you have lots of fish in the water, you have more variance. You have more variety in the response, and you will have some fish, because you have more, that can resist better, are more resilient to temperature. So basically, the moral of the story, what you have to do is to leave as many fish as possible in the water. And leaving fish in the water is what we do in marine protected areas. So we we have to create more marine protected areas and to manage stocks to leave enough of them in the water, which is also good for fisheries because they make more money if there is more fish in the water.
Okay, next question.
So the zooplankton and the phytoplankton also have preferred temperature. And basically, when the fish move toward the North Pole in the Northern Hemisphere and toward the South Pole in the Southern Hemisphere, the zooplankton and the phytoplankton will also do that. So you can say that it's the whole ecosystem that moves. However, it doesn't move, not all elements of the ecosystem move at the same rate. So basically, you could have a fish moving, but the prey of the fish is not moving. Or you can have the prey of the fish moving, but the fish is not moving. So you can expect lots of disruption. For example, we have now here Humboldt squid, large squid that have no predators. And that is because the predators have not moved, but the large squid has moved. So basically, the zooplankton and the phytoplankton adapts very fast because they have a small, shorter lifespan, and they turn over very fast. So zooplankton and phytoplankton can adapt a bit better than fish, with and the disruption, because they don't adapt at the same speed, will cause disruption in ecosystems. Yeah, the perspective for cold water fish are problematic. For example, truchas, the trouts, are in many environments are not fit anymore because it's too warm, and the oxygen requirements are not met, and so the fish that are adapted to very cold water are in trouble, and they are first getting a bit smaller, and then they don't fit anymore. And it is clear that if we do not manage to turn around the warming, if it continues to warm, they will be the first species to disappear. They will be the first species to disappear. This cold water species will be the first to disappear. And we see that, for example, the bacalhau is a species that is very well adapted to varying temperature. And in the North Atlantic, it is replacing cold water species, that polar species that were adapted to live in very cold water, because it's now getting warmer, and bacalhau is the invasive species that is coming from the south of the North Pole. So I mentioned the Mediterranean. I already mentioned the change in the ecosystem is the Mediterranean Sea is enormous, especially in the Eastern Mediterranean Sea, because of the Suez Canal, and fish can get from the Indo-Pacific into the Red Sea, through the Red Sea into the Mediterranean. So if you want to see the future, you look at the Eastern Mediterranean, which is full of invasive species, and a few fisheries for traditional fish that are from the Mediterranean have collapsed because they are not there anymore. And also fish have invaded that, for example, eat all the seagrass, and that is very bad. There is a fish called Siganus, rabbit fish. They eat seagrass, and the seagrass are very important in the Mediterranean, and the seagrass are then threatened by this invasive species. Yep. Oh, Jaime Mendo, hello. So to the temperature preferred by species is what we use is the temperature, the average temperature at the center of the distribution. If you plot the distribution of a species, it will cover warm water and cold water, but at the center of the distribution where it is most abundant, it's where the preferred temperature is. That's what we use for to estimate the MTC. And there is a software. It's called Aquamaps that gives temperatures for lots of species. So, yeah. With regard to migration, that will depend locally. The migration are not all due to temperature change. For example, in the Amazon, it's not temperature that change. It's everything. The high water, low water is connected with temperature, but not so much. But in the marine world, when the temperature gets low, or too low, they go away and they come back when the temperature is right. When it's too hot, they go away and they come back when it's right. But it will depend on the local condition. Generally, you can say on the northern hemisphere, the fish go further north in the summer and they go further south in the winter. And it also applies to the southern hemisphere, except that it is different month. Yep. So it is very difficult to show that tropical fish are being affected right now, because in the tropics you have lots of species and not many researchers. So it's very difficult to demonstrate that a species has not been overfished and has not disappeared because of pollution and has disappeared because of the high temperature. In other words, pollution in freshwater and coastal waters, overfishing and high temperature work the same way. They reduce the certain fish, and it's very difficult to separate them. But we have evidence that of movement that are induced by the temperature in a subtropic and in a temperate zone. And for the tropical zone, we have to assume that there is no reason why they should not behave like the other fish. This is very difficult to demonstrate that a given species is declining because of global warming. It is not, obviously the fishers will say that, oh, this is not us who have overfished the fish, it is because of climate change. But they are difficult to separate this effect. I admit that. So thank you for the compliment. I was confused a bit, but the map that I showed you shows that the countries that will be most affected are countries that are completely in the tropics. So, for example, a country like Indonesia, which is along the equator, will be more affected than a country that is like Argentina or Chile, that goes from north to south. And so countries that are inner tropics only will be most affected. And that is unfair. That certainly is unfair, because these countries are not the one that have produced all the greenhouse gases, but they will be most affected because the fish that are leaving the tropics are not replaced, whereas the fish that are, for example, leaving California in US, will be replaced in part by fish from Mexico, right? So you take US California, their fish move to British Columbia, where I live, and but their fish are being replaced by Mexican fish. But in Mexico, and further down toward Panama and so on, there is no fish to replace the species that are leaving. So that would be the tropical countries. So basically, a good point. Echinoderms, sea urchins, and sea cucumbers have no gills, really. But the problem that they have is that they breathe water. All animals that breathe water with gills or using other organs have the same problem, that water doesn't have much oxygen, and that it is difficult to get this oxygen into their body, and so they will be affected the same way. And really, the theory that I presented should not have gills. It should have respiratory organs, because it's valid for all water-breathing animals. In fact, I've written now several papers about invertebrates we can show that they are affected the same way as fish. And I'm very happy that you are using the CMSY. I would recommend that you use a newer approach, because the Martel-and-Froese method has been improved a lot. It's called CMSY++. And no, the model does not include temperature. If you have 20 years of data, for example, you can actually do the assessment without considering temperature. If you do the assessment over 60 years, if you have data that goes 50, 60 years, then perhaps you have to consider the expansion of the range, and this would the change in carrying capacity. But for most assessment, where you have a shorter temperature, a shorter time series of catches, you don't have to take account of global warming. And in fact, this simple model that is called now CMSY, I will send you a newer version if you write me an email. The model doesn't allow for including temperature. No, we didn't do we didn't project the effect of stock biomass instead of a catch, because at the time when we did these papers that I showed you, we didn't have stock biomass for all of this, for all of these stocks. We do now, and I expect in the next years that we will present analysis that includes the biomass moving toward the poles, North Pole and South Pole, rather than the catch. Yeah. Yeah. So if you, it's true that if the fish get smaller, they will reproduce at a smaller size. So the question is, well, then let's catch them smaller. but it makes everything worse, right? Because if you make them even smaller, you will have even fewer big ones, and then you will have a genetic effect added to the effect of temperature. Because if you fish big fish for a long time, there is a genetic effect on the fish that they become smaller. So basically they become smaller because we fish the big ones, and then they have problem breathing. And so basically the problems get added. They have problems with breathing, and then they have problems surviving to maturity, and then they have problems because they get caught. Basically, if we want to have fewer problems, and if we want stock to maintain themselves, we have to leave them alone for a while, and that's why we need marine protected areas with no fishing. That's a good question. I don't know. I would think that fish that have a higher metabolic activity would be more contamination products would be ingested or assimilated, and they are likely, I think, to be more susceptible to aquatic pollution. But I don't have any specific demonstration of this in mind. This is for me a new point, a new issue. But I don't work on pollution. This is a good question that is worth looking at. Claudia, you should look at it. Yeah.
Well, I think we have no further questions.
Very nice.
It's been very great presentation and very interesting, all the topics that have been discussed through the questions, and even a new research line has just been pointed out.
Yes, it does, because we always look at what they eat, because to us, we mammals and birds, they eat a lot because we have to maintain our temperature. For fish, they don't have to maintain their own temperature because they have the same temperature of the water. So they eat much less than us, but getting enough oxygen to burn what they eat, because that's what oxygen does, right? It burns, it allows the body to burn and to generate energy. It is difficult for fish. And so people don't think of this, they cannot think themselves as a fish. But if you think yourself as a fish, like, you cannot breathe properly, that you begin to understand what they go through. And even for aquaculture is helpful, because you saw this picture, and that's my last point. You saw this picture of this Chinese aquaculture. They have huge amount of money invested in aerating the pond. Why do they do that? Because aerating the pond means that the food is better used, is converted into flesh. If you don't have enough oxygen, you cannot, as a fish, you cannot use the food. The food will be wasted. So by adding oxygen into the water, they enable the food to be fully utilized. That is an important point. Okay.
Well, thank you very much.
Pleasure.
Muchas gracias a Daniel por la excelente contribución que nos ha traído y a todo el público participante por esta interesante presentación. Le hacemos la invitación para mañana a las 10 de la mañana, hora de Panamá, Colombia, Ecuador, Perú, donde vamos a tener nuestra primera sesión de la reunión del X FIRMA, y vamos a estar hablando precisamente de recursos marinos y la pesquería. En este caso, José Aliot va a ser el moderador de esta sesión y los invitamos para que no se pierdan ninguno de las actividades que tenemos preparadas. Bueno, con esto creo que podemos dar por concluido esta inauguración. No sé, César, ¿tienes algunas palabras que decir?
No, bueno, agradecer a Daniel la presentación. Una cosa, Daniel, quedaron muchas preguntas sin contestar. Tú podrías tener la amabilidad que por correo electrónico podrías contestarlas en tu tiempo disponible.
Ya. Voy a respetar. Si alguna pregunta, todos pueden mandar un correo y yo voy a responder.
Ok, cualquier cosa, si quieren, me pueden mandar la pregunta a mí y yo se la hago llegar a Pauli o a Marcos, no hay problema. Entonces, gracias a todos, Marcos, gracias a ti por todo lo que has hecho a todos ustedes atendiendo esta espectacular ponencia que en el caso de nosotros los acuicultores pues nos da mucho que pensar en los trópicos, ¿no? Y poder hacer estrategias. Yo creo que la genética va a tener mucho que ver aquí, Marcos, para poder nosotros llevar a unos estados mucho más productivos los trópicos y poder canalizar las altas demandas que se vienen a todos los niveles. Por nada, pues muchas gracias y sean ustedes familia FIRMA.
Los esperamos entonces mañana a las 10 de la mañana.
Gracias a todos.